Let's look at one more question about angles of elevation and angles of depression. So it is the design of a cable car system. Suppose it is like the Ongping 360 cable car system, right? So it goes up the hill, but the hill is not uniform in the slope. Alright, so we have two stages in the slope. We have OA and AB. OA is more gentle. The inclination is 20 degrees. AB is steeper, the inclination is 30 degrees. So 30 degrees is the angle the line AB is making with the horizontal. Okay. So now we stretch a cable between O and B. Right. OB is the cable car. Alright. And point A is 150 meters above ground. Point B is 250 meters above ground. So the question is, how long is the cable car ride? How long is the ride OB, right? If these are all the cable cars going uphill, all right, what is the length of the entire OB, the ride, all right? So once again, we can get the focus triangle. Right? Now there are two methods we can do it, right? Let me show you. First one is we don't need any trigonometric formula. We can do it with Pythagoras Theorem. Alright, we can split it into right angle triangles. Right, if you take a look at here, you see there are actually three right angle triangles. This is one, this is the second one, alright, and there's a third right angle triangle all the way here. Right, there's a third right angle triangle all the way here, in the gray one. Alright, so in each right angle triangle, you can put down the value. This is 150. Alright, the whole thing is 250. That means the smaller part here is 100. Alright, the whole length here is 250. Now as for the angles, this one is 30 degrees. Sorry, this one is 30 degrees. This one is 20 degrees. Alright. So we can get the horizontal distance one by one, right? The orange one, we can get it with 150 and 20 degrees, all right? And then we can also get the green one. The green one is taken from here, all right? This is also the green one, and that is you can find it with 130 degrees, all right? It turns out that this one is 150 divided by tangent 20, right? And the green one is 100 divided by tangent 30. Alright, so the entire length will be the sum of these two numbers. And then eventually you can use Pythagoras Theorem. Alright, this squared, green and orange squared plus 250 squared. Take the square root. That would be the answer of OB, right? That would be the length of the OB. Right, now in this method, I use entirely with right angle triangle. I did not use any sine nor well, I used some trigonometric ratio, but I did not use the sine formula nor the cosine formula. But you have to be very careful on the trigonometric ratio, right? This orange and the green numbers. This is essential to get those correct if you adopt this method. Alright, this method works because of these right angle triangles. Alright, now if you want to know the answer, this one, according to my calculation, is 636.5 meters. Okay. Now, alternatively, you can do it with the cosine formula or the sine formula, right? Of course, we need the focus triangle, right? So let me highlight the focus triangle. I think I will pick this one as the focus triangle, right? And the blue line and the red line, they come from, yet another right angle triangles. The blue line will be this one, all right? And the red line comes from AB, all right? So like we said, this one is 100, all right? And it is a right angle, and the angle here is 30 degrees, all right? Likewise, we have this one is 150. This angle is 20 degrees. So we can get the red line and the blue line respectively. The blue line will be 150 divided by sine 20 degrees. Am I right? 150 divided by sine 20, because sine 20 is 150 divided by the blue. Alright, sine 20 is 150 divided by the blue. So we have the blue equals to 150 divided by the blue is OA. Alright, it's 150 divided by sine 20 is 20, not theta. And similarly, the red line will be 100 divided by sine 30. Alright. Okay, once you have the red line, you have the blue line. In the focus triangle, you need one more angle. Alright, you need one more angle. And the angle here, we can find the angle in between, the purple angle between the red and the purple, right? If you refer to the diagram, that is the purple angle here. Alright, and that purple angle is 180 minus 30 plus 20. The purple angle here, if you look at what happened around here, you have at point A, and let me put back the horizontal line. The horizontal line will be like this. Alright, so this is 30 degrees as the inclination of AB. Oops, sorry. It's 30 degrees as the inclination of AB. And because it is 20 degrees down here, alright, so it must also be 20 degrees because they are interior angles. So altogether, the entire purple angle between the red line and the blue line will be 180 minus 30, right, plus 20. And that goes to 170 degrees. 170 degrees, alright. So this is a typical SAS situation. We can use cosine formula SAS to find the distance of OB. Alright, we can use SAS cosine formula to find OB. Alright, and you can do it with manually, or you can do it with the calculator formula. On your Casio calculator, it is formula 02, remember. It is formula 02 for OB, and I believe the answer goes to the same 636.5 meter to 1 decimal place. Alright. So in the second method here, I use extensively the idea of sine formula. In this particular case, it's cosine formula. I use some sine cosine ratio and the cosine formula. And note, how do I find out the purple angle? Alright, the red line and the blue line, they come from the trigonometric ratio. The purple angle comes from the indirectly from the given information. Okay. Now, but let's have an extension of this problem, right? Suppose we have a tree at the position of A. Alright, the tree is 20 meters tall. This is the height of the tree. It is an ancient tree. We don't want to cut down the tree to make the cable car running. Alright, so the question is it an acceptable site to build the cable car from OB if there is a tree in between? Alright, in other words, is there enough clearance for the tree at A? Alright, is the cable car high enough to clear the tree, or will it collide into the tree? Alright. So how do you find the clearance between the point A and the cable car? Alright, so let's suppose we extend PA. Alright, we extend the PA and allow it go up. Alright, let me do it in pink. Alright, we allow this line to go up. Suppose this is the tree. Alright, we can calculate how much clearance are there. If this pink segment is less than 20, then the tree is okay, right? You don't have to cut down the tree. If this AX segment is less than 20, if AX is less than 20 or equals, right, then the cable car hits the tree. You have to cut down the tree, alright? On the other hand, if AX is greater than 20 meters, then it clears the tree, alright? It is clear. The cable car can run without hitting the tree, alright? So now the entire question is focused on finding the distance AX. If AX is less than equal to 20, then it hits the tree. If it is less than 20, then it is clear. Right? It can go above on top of the tree. So that we have to find AX. All right. Now to do that, once again, we need the focus triangle. We can do it with the focus triangle on AXO. All right, this one. Point O is somewhere here, right? And the cable car is OX. All right. So we can do it in the triangle OAX. All right. Alternatively, you can do it in triangle ABX. All right. You can choose either one as the focus triangle. You might choose this one as the focus triangle. I will demonstrate one method, right? You can work out the other method on your own. So this is the other triangle. All right, either way is okay because all we need is to find the distance of AX. All right. And the decision point is whether AX is greater than or smaller than 20. If it is greater than 20, then all is good. If it is less than 20, either we have to cut down the tree or we have to find alternate sides. So I will do it with the first triangle I mentioned. All right, I will do it with OAX. Since we already did OA, right, in the previous section, OA is the blue line here. All right, so we already did OA. We know that OA is 150 divided by sine 20. Oops, sorry. OA is 150 divided by sine 20. Alright, but there's only one piece of information. Alright, we don't know OX, we know OB, we know the entire length OB, but you cannot say X is the midpoint. Alright, you don't know where X is, so you cannot take half of OB. We have no idea about OX, we have no idea about OA, about AX. AX is what we need to find, right? So we have to resort to the angles. Can we find the angles? Can we find the angles? Well, perhaps we can find this purple angle, right? Perhaps we can find this purple angle because, you know, this purple angle will be 90 plus 20, right? If you put back the horizontal line, you'll discover that it is the horizontal line, and the slope is making 20 degrees with the horizontal line. All right, this is 20 degrees with the horizontal line, and the other angle is a right angle. So the purple angle goes to 90 plus 20 is 110 degrees for the purple angle. All right, so we need one more angle. We need one more angle. We can find out this angle, this green angle. All right, because this green angle plus 20 degrees will become angle BOQ. All right, because you know BO. All right, so the entire angle, let's call it theta. All right, so we know theta plus 20 degrees. Theta plus 20 degrees, the sine ratio will be BQ 250 divided by OB. All right, OB is the length of the cable car we just found. 250 divided by what was the length? 636.5. All right. Now I would better keep it in more decimal places because the intermediate result usually take two more digits in order to get the intermediate result correct. All right. Anyways, so we have the angle theta. Theta will be the inverse sine function of BQ divided by OB and then subtract 20 degrees. All right. Now I will do it on the calculator later, but this is what OB is. Now, normally, when you take the inverse function of the sine theta, you have to worry about the obtuse angle counterpart. There are two solutions. One of them is acute angle, the other is obtuse angle. But in this case, we don't have to worry about the obtuse angle. From the diagram, clearly it is an acute angle, right? The whole thing does not work. The cable car does not work if the green angle is an obtuse angle. Then the cable car goes that way. It goes the wrong way, all right? So it is obviously from the context, it cannot be the obtuse angle. So you just pick the acute angle. So anyway, that would be theta in green. All right, BQ is 250. OB is the answer we just obtained previously. Anyway, so we have theta. Once you have a theta, it is again a typical ASA situation. ASA situation. We have the green angle A, we have the blue line, and we have the purple angle. So using the ASA in apply ASA sine formula in triangle OAX, we discover that AX, of course, there needs some calculation inside, right? But anyway, I hope you can find X from here. Can you do that on your own? Alright, using the green angle is theta, the blue line and the purple angle. You can use ASA in triangle OAX to obtain AX. According to my calculation, AX is 26.03 meter. Alright, so the tree can be kept. You don't have to cut down the tree. Alright, you can keep the tree. It is high enough to clear the tree. Alright. Alternatively, you may want to do it in the other triangle. If you have the time, you can try how you can do it in triangle AXB. Alright. Alright, so this is pretty much about angles of elevation and depression.